video, we address inference on means based on two samples. We often want to know whether a mean value, for example a mean return, differs between two groups. A t-test based on two independent random samples with equal but unknown population variance is given by t equals to the difference in the sample means minus the difference in the population mean divided by this pooled estimator of the common variance, where the pooled variance takes the following form. The number of degrees for this t-test is n1 plus n2 minus 2, where n1 and n2 are the sample size for sample 1 and sample 2. The best way to learn this concept is to look at an example. The realized mean monthly return on S&P 500 index in the first half of 2000s appeared to be substantially different than the mean return in the second half of 2000s. Test if the means were statistically significantly different at 5% level of significance. And the following table provides the required data. Letting mu1 stand for the population mean return for 2000 through 2004 period and mu2 stand for the population mean return for 2005 through 2009 period, we formulate the following hypotheses. Null hypothesis is equal to mu1 minus mu2 equals to 0 versus the alternate hypothesis, which is what we are interested in testing, is mu1 minus mu2 is not equal to 0. Because the two samples are drawn from two different time periods, they can be assumed to be independent samples. The population variance are not known but can be assumed to be equal. And based on the data shown in the table, it seems that the assumption of equal population variance for returns in 2 decades is not unreasonable. Given all these considerations, we use the following t-test for testing our hypotheses. T equals to the difference in the sample mean minus the difference in the population mean divided by this pooled estimator of variance. The t-value would have n1 plus n2 minus 2 or 60 plus 60 minus 2, 118 degrees of freedom. From the t-table, we find that for a two-tailed test, the rejection points associated with 118 degrees of freedom and 5% level of significance are plus minus 1.980. Hence, we will reject the null if the calculated value of t is either less than negative 1.980 or if the calculated value of t is greater than 1.980. In calculating the test statistic, the first step is to calculate the pooled estimate of the variance as follows. Now we can plug in all numbers in the formula to calculate the t-values as follows. Since the calculated t-value of negative 0.27 is neither less than the rejection point of negative 1.98 nor greater than the rejection point of 1.98, therefore we do not reject the null hypothesis at 5% level. Hence, we can conclude that the mean monthly return on the S&P 500 index in the first half of 2000s is not statistically different than the mean return in the second half of 2000s. The t-test discussed thus far only works when the unknown population variance for the two samples can be assumed to be equal. If the equality of variance assumptions do not hold, then we should use the following t-test. T equals to the difference in the sample mean minus the difference in the population mean divided by the pooled variance estimator. For this t-test statistic, we use the modified degrees of freedom computed as follows. Let's look at an example. While examining the recovery rates of defaulted bonds in the US corporate bond market, it is found that electricity firms recover more during bankruptcy than firms in the retail industry. We want to test if the difference in recovery rates between these two types of firms is statistically significant at 5% level of significance using the following data. Assume that the population or recovery rates are normally distributed and the samples are independent, with mu1 denoting the population mean recovery rate for bonds in electricity firm and mu2 denoting the population mean recovery rate for bonds in retail firms. The hypothesis can be written as null hypothesis of mu1 minus mu2 equal to 0 versus the alternate hypothesis, which is mu1 minus mu2 is not equal to 0. The alternate hypothesis is the claim that we want to test. The sample standard deviation for the recovery rate on the bonds of electricity firm is $22.67, which appears much smaller than the sample standard deviation of the bonds for the retail firms, which is $34.19. Therefore, we should not assume equal variance, and accordingly, we should employ the alternate t-test given by the following equation. Here, X1 bar is the sample mean recovery rate for electricity firm, which is equal to $48.03. X2 is the sample mean recovery rate for retail firms, which is equal to $33.40. S1 squared is the sample variance for electricity firm, which is equal to 22.67 squared or 513.9289. S2 squared is the sample variance for the retail firms, which is equal to 34.19 squared, which is equal to 1168.9561. N1 is the sample size for the electricity firm's sample, which is equal to 39, and N2 is the sample size for the retail firm's sample, which is equal to 33. Plugging in all of these numbers in the formula gives us a t-value of 2.099 with 56 degrees of freedom. The closest entry to degrees of freedom of 56 in the tables for the t-distribution is degrees of freedom of 60. Since this is a two-tail test, we'll look at the table with 60 degrees of freedom and 5% divided by 2 or 0.025 column. We find the rejection value of 2. Since our calculated value of 2.099 is greater than the rejection value of 2, we reject the null hypothesis at 5% level. These results provide evidence that the recovery rates differ between the electricity and the retail industry.